All right, in this one, we're looking at complex rational expressions. And a complex rational expression is more often called a complex fraction. And what that means is we have fractions inside our fractions. Either the numerator or the denominator or both also have fractions in them. And we've talked about this a little bit this year, that we don't like to have fractions in our fractions. So the best way to simplify these, and I wouldn't even say the best way because I'm going to show you actually two methods to do this. So one way to simplify these is to treat the numerator and the denominator as separate problems. Then that fraction bar, remember, represents a division symbol, so it's just a division problem. Okay? The other option, method 2, is going to be to multiply top and bottom, both the numerator and the denominator, because remember that's equal to 1, by the LCM of all fractions. Okay, I'm going to show you both methods on number 16 so that we can see what we've got there. The excluded values get kind of tricky with these. It's going to come from any step throughout the process where the denominator could be 0. So you have to kind of check every single step. Was there a divide by 0? Was there a divide by 0? That's what you're looking for. So let's look at number 16. We want to simplify. This is a complex fraction because there's a 1 over x in the top and a 1 over x in the bottom. So I'm going to show you both methods so you can decide which one you like better. So method 1 is that we're going to treat it like separate problems. So the first thing I'm going to do is get a common denominator here and then get a common denominator here. So in order to do that, we would want to multiply the 1 by x over x plus 1 over x. That'll make our common denominator on the top x. And then same thing down here. If I multiply this by x over x, then both of them have a common denominator of x. So the top fraction then becomes 1 times x, so that's x plus 1 over x, and all of that is over x minus 1 over x. Now remember that fraction bar just means division, so now we're going to keep, change, flip. Keep the top fraction the same, x plus 1 over x. Change it from division to multiplication. Multiply by x over x minus 1. Now you can see the x's are going to divide out, and so we get x plus 1 over x minus 1, and that's going to be our answer. All right. Excluded values here would be 0 and 1 because originally x could not be 0. Here, x cannot be 0. Once I get to the end, x cannot be 1. And so 0 and 1 would be our excluded values. So that's your first method. Depending on the problem, that's going to be more work. So you definitely can choose. Method 2 is the one that I like better. Multiply by the LCM of everything. So if we start with this fraction, 1 plus 1 over x over 1 minus 1 over x, this is an example of where this one is much faster. The LCM of 1 over 1, 1 over x, 1 over 1, and 1 over x is just going to be x. Okay, so what we can do is multiply this fraction by x over x, whatever your LCM is. When I do that, remember there's implied parentheses here and here, so we have to distribute. And so we get 1 times x, which is x, plus 1 over x times x. Those x's cancel, so we're just left with 1 over, similarly, x minus 1. And so there's our answer. So you can see on this particular case, method 2 is much faster. But either way will work. If you want to just stick with what you've been doing, do method 1. Let's look at another one. Number 17. This one has a little bit more going on. So if we look at what we have, method 1 would be to essentially treat this like two problems. So here's another way that you can kind of think about method 1 if we think kind of in terms of our order of operations. The first thing we're going to do is the top problem, x over x minus 2 plus 1, and then we're going to divide that by the bottom problem, 3 over, I'm going to factor this, x plus 2, x minus 2, and then plus 1. That's the process that you're following. It's always going to be the top problem divided by the bottom problem when you're doing method 1. So we'd have to multiply here by x minus 2 over x minus 2. That's going to give us x plus x minus 2 all over x minus 2. So that gives me 2x minus 2 over x minus 2. Okay. Divided by, inside here, again, this is over 1, so I need all of this to be my common denominator. X plus 2, x minus 2, x plus 2, x minus 2. So this gives me 3 times, x plus 2 times x minus 2 is x squared minus 4. And we may as well leave it factored, actually. Keep talking about that. The factored form is going to be more useful so that we can cancel stuff out. So let's leave it as x plus 2, x minus 2. And that's over, oh, I'm sorry. This is not right. I'm ignoring this plus sign right here, okay? So we don't actually want to multiply by 3. We want 3 plus x plus 2 times x minus 2. That's why I wanted to multiply it out so that we can combine those like terms. Sorry to make you rewrite that. Okay, let's combine our like terms and factor if we need to. This is going to be where we keep change flip. So I see on this first one, 2x minus 2, that I can factor out a 2. X minus 2. And then I'm going to say times x plus 2, x minus 2. We're flipping this fraction now. The top of this is going to become x squared minus 1. So that's x plus 1, x minus 1. Now this is just multiplying. So let's see what we can eliminate here. X minus 1 over x minus 1, that's a 1. X minus 2, x minus 2, that's a 1. And nothing else. So this is going to become 2 times x plus 2 over x plus 1, and that would be our answer. 2, negative 2, that came from the original problem. Those are excluded, but also 1 and negative 1, because of the flip, have to be excluded in this case. All right, let me show you method 2. Again, this is the method that I prefer. So the first thing we have to look at is what would be the LCM of all of the denominators. So we have x over x minus 2. We have 1 over 1, so that doesn't really matter. And then we also have x minus 2, x plus 2 when we factor that. So do you see if I just multiply the first one by x plus 2, then the LCM is going to be x minus 2, x plus 2. That's what we're going to multiply everything by. So we take our fraction, x over x minus 2 plus 1 over 3 over x plus 2, x minus 2 plus 1. And we want to multiply the whole thing times x plus 2, x minus 2. Top and bottom, because remember, we're only allowed to multiply by 1. Okay. We have to distribute. So when I multiply here, I have x times, the x minus 2's are going to cancel. So I have x plus 2. And then I have 1 times this, which again was x squared minus 4. That's what it was before we factored. Down here, when I multiply the first time, they're all going to cancel out. So I just have 3 plus x squared minus 4 again. Now, don't get tempted to cross out those x squared minus 4s. You cannot, because remember, those are terms, not factors. We are only allowed to divide out factors. Give myself a little more room there. Okay, so let's combine this stuff together. X squared plus 2x is what we get there. So we're going to have 2x squared plus x squared, and then 2x, there's nothing to combine with, so plus 2x minus 4 over x squared minus 1. We're almost there. We just need to factor this stuff. Let me come over here where you can see it. Whoops, not that far. So on the top, we can factor out a 2, and that's going to leave us with x squared plus x minus 2. Over x plus 1, x minus 1, which we can factor again to x plus 2, x minus 1. And now we can see that these are going to divide out. And so the final answer, I'm running out of space, so I'm going to be kind of lazy right here, is that, which is exactly what we had gotten before. Neither one of these is particularly faster in this case. It's definitely a preference of which strategy feels more comfortable to you. And these are tricky, so you just got to take it slow. And it's just like finding a common denominator. You can either find the common denominator separately in method 1, or you can find the common denominator as a whole, looking at all of the denominators in the entire fraction. Either one will get you to the right answer, whichever one you like the best.